Welcome to Neurochem Lab, a space where we discuss the intersection between neuroscience, education, and technology, and provide research and practical insights for educators and students to help them with their teaching and learning. I'm 𝗿𝗵𝗲𝗰, and I am currently a neuroscience graduate student at the University of Texas at Dallas. I am also your host for today. I am happy that my first guest on this show is Dr. Eric Chudler. Dr. Eric Chudler is a research associate professor in the Department of Bioengineering at the University of Washington. He also manages a website called Neuroscience for Kids, where he sends a monthly newsletter for educators and parents, sharing with them neuroscience activities and resources that they could teach their children. Today, we touch on a spectrum of topics within the boundaries of neuroscience and education. For instance, we discussed the importance of teaching neuroscience to children and how it could help them build a better life centered around healthier choices. This conversation is ideal for educators who are interested in integrating neuroscience in their curriculums, but also for STEM undergraduate and graduate students to see how neuroscience intersects with other fields. I hope you enjoy my conversation with Dr. Eric Chudler. Hello, Professor Eric Chudler. Welcome to Neurochem Lab. I really can describe how I'm excited to have you and to talk to you. I came across your website, Neuroscience for Kids, almost a year ago when I had the idea that why not teach neuroscience for children? I just Googled neuroscience for kids and your website was the first webpage. I remember spending like an hour navigating the entire sitemap and just exploring what kind of topics you have mentioned. As I was looking you up more, I noticed that it's not your main focus. You're doing a lot in research. How long have you been doing it and how does it fit in your extensive research portfolio?
Yeah, well, first of all, thanks for having me. It's great talking to you. I'm glad that you found me. Yeah, Neuroscience for Kids has been going on for close to maybe 30 years. So I started it when this internet thing was somewhat new. And I thought, well, maybe this internet can be used to teach people. And so I taught myself HTML and a lot of the materials that I was using, even before the website, I was going into classrooms. So when my daughter was in preschool, I would go to her preschool classes. And then as she went to the next level, I would go to that classroom. And so I was giving the teachers these materials. And I thought, what better way than to distribute this with this thing called the internet? So I put all of these materials on a website. I called it Neuroscience for Kids, but as you may have noticed, it's really good for anybody. There's material not only for elementary, middle school, high school kids, but I think even undergraduates and maybe even some graduate students might learn something new from the material. So that's kind of how it got started. And then I wrote a grant to the National Institutes of Health, and they funded it through something called a 𝗖𝗵𝗲𝗰 grant, which stands for Science Education Partnership Award. And it was not only to develop those materials, but to evaluate those materials to ensure that teachers were getting something out of it and that students were learning. So that's kind of how it got started, really through my daughter and then through this grant from the National Institutes of Health.
And it's not what you're doing full-time. What else are you researching, or what is your main research focus?
Yeah, so at the University of Washington, I'm a research associate professor. My core appointment is in the Department of Bioengineering at the University of Washington. My lab is in the Department of Anesthesiology and Pain Medicine. My office is located in the Department of Computer Science and Engineering. So I split my time in those different domains. In addition to my faculty appointment, I'm also the executive director and the education director of the Center for Neurotechnology. We're developing technologies that can be integrated into the body to help people who have suffered damage to the nervous system, for example, stroke or spinal cord injury. So I help manage some of that work. That's not my research focus, though. My research focus currently is I'm looking at the neuroactive properties of medicinal plants and looking using an invertebrate bioassay using these little worms called planaria, which are amazing animals that have this fantastic ability to regenerate. And I'm looking at different properties of plants that can either speed up the regeneration or perhaps are detrimental to the organism and maybe are bad for development.
And a monthly newsletter for neuroscience for kids.
Yeah, and the website's not currently funded, so I do the website just on my own time. With that, the newsletter, and I try to add materials to the website as they become available. So it's when it was funded by the National Institutes of Health, I had staff that was able to help me and things like that. But now it's just something that I like to do on the side.
It's like a passion project.
I guess you could say that, yeah. And I still get letters from students and teachers who appreciate the materials that are there and still used in classrooms. A lot of neuroscientists, students who do outreach, for example, during Brain Awareness Week. They get a lot of ideas, and all the material is available for free. And I think that a lot of it is very adaptable to different audiences. So that material is just all freely available for people to use.
I will put a link to the website in the show note captions, and it's very extensive. There's so much in it, and everything is simplified. Everything is gamified. There's like practical activities that any educator could use. So you mentioned that you used to go to the classroom and you would do the activities, or would you train teachers to do the activities and rotate around that?
I've done a little bit of both. So yes, I still go out to schools. Again, it's not something that's built into my regular job, but when a teacher asks me to go, if I'm available, we can usually make arrangements and I'll go visit a classroom, or a teacher can come visit me. So I do maybe one or two, I call them field trips, where a teacher will bring maybe one classroom, sometimes two classes will come to me at the University of Washington, and I'll talk to them for about an hour, hour and a half. But yes, I've also done workshops for teachers in the past, trying to give them ideas about how they can incorporate neuroscience into their classrooms. And sometimes I've worked with graduate students who would like to go out into classrooms or host their own field trips. And so I work with a couple student groups at the University of Washington to help them during their efforts.
Very interesting. And how do you think it's like the best approach to translating complex ideas to students in the classroom?
Yeah, well, it's always challenging because, as you know, the words that we use in neuroscience are Greek and Latin, and they're really Greek and Latin. And so a lot of the terminology that we use as neuroscientists is sometimes difficult to understand. And certainly, I think that a basic knowledge about how the brain works is essential. So I, do a basic, this is your brain, a little bit of neuroanatomy, a little bit of neurophysiology, a bit about neurotransmission. I think it's essential that students know that the brain uses electricity and that an electrical signal is converted to a chemical signal when they go from neuron to neuron. So I think a basic understanding is very important. And one way to convey those concepts is through hands-on activities. And so, yes, I can say these things, but I think that it's also very valuable to actually do these things. So we can model how the nervous system works with very simple materials, with candy making neurons, with games to show how an electrical signal is converted to cause a chemical release from a terminal to cause neurotransmitters to the other side. So we can play games that I think are very important that help students learn the concept. So a combination of talking, but then a lot of activities and a lot of active learning.
I came across neuroscience because of the internet. I wasn't studying neuroscience in my undergrad. I was in the science field. I was studying chemistry, but that was a bit they didn't connect it to the brain or the body. So when I started reading about the stuff, like how the brain works, the communication between cells happen, it really fascinated me because this is knowledge about my own body and my own brain. And this is why it really put into me this motivation that everyone should learn. So when teachers are reading a book on neuroscience or talking with neuroscientists, they aren't only doing it for their classrooms and their kids, they are even doing it for themselves, because there's so much importance that happens when we learn about the brain. And I'd like to ask you about this importance. Like, what is the importance from your perspective to learn neuroscience at any age? And then we can move specifically to the elementary and middle school age.
Sure. Yeah, I think you bring up some excellent points. And there's many reasons why everyone needs to learn about the brain. The first one, I think, is that unfortunately, neurological and mental illness is so common. Unfortunately, we will probably know someone or ourselves may be affected by disease that affects our brain. These things could be suffered by our grandparents, maybe with Parkinson's disease or Alzheimer's disease. These are very, very common. Or younger students might have friends who have fallen off their bikes, hit their head, suffered a concussion. These are very, very common diseases. And these diseases take a tremendous toll on people, both emotionally, dealing with someone who has suffered from one of these conditions, and it's expensive. So younger kids probably don't have to worry about the monetary costs, but these diseases are so common that we'll all know someone who's been affected by them. And so I think that by knowing more about how the brain works, how the brain changes when it's injured, are very important for people to understand what's going on with a person who suffered from one of these illnesses. Stroke. So stroke is extremely common. And so if a young child has a grandparent who has suffered from a stroke, might be afraid. But by knowing more about how the brain works, about knowing more about the stroke, it's not, having a stroke is not contagious, for example. Alzheimer's disease is not contagious. And so by knowing more about these illnesses, I think that any person will be able to cope more and maybe even help people who have suffered these types of conditions. Another reason is that I think it's difficult to read a book, read the newspaper without seeing some story or article about the brain. So just basic science literacy, it's important to know about how the brain works. So being able to understand what we read, how to critically analyze what we see on the internet, what we see on television, to critically analyze and understand what we see and hear is very important as well, so that we can sort of separate fact from fiction.
I agree. And I think it's also like, if we look at everything that we do during the day, anything could be improved with understanding our brain, like understanding our sleep, understanding our diet, understanding what to consume, especially now with the way we are consuming media, specifically social media, and the way social media is built to hijack the brain. If we had some literacy and some awareness of what is happening, not fall into the way the user interface is built in an app, for example. I found an article that you wrote in Nature magazine, I think in 2006. It was titled A Role of Neuroscientists in Engaging Young Minds. One excerpt from the article was a survey that you mentioned of 43,000 students, that half of them have tried a drug by the time that they finished high school. You mentioned that neuroscience is relevant to a healthy lifestyle. And I think it's scary how now with children, they are easily exposed to these kind of drugs. So neuroscience education, how do you think it could help us build a healthy lifestyle?
Yes, I agree with you completely. Yes, I think that, yes, knowing about the brain can contribute to a healthy lifestyle. And this is not only related to the intake of drugs, but also wearing helmets, as you mentioned, getting enough sleep, having a proper diet. These are all things that we know that there's good data to suggest by having these healthy lifestyles will affect our brain in later life. So yes, I think that is critical. But I think especially when it comes to drugs, we have to be careful with the message. And that is, we know that in the past there was the just say no to drugs, and it didn't work. That didn't work.
Yeah.
And I think we also have to be a little bit careful about how we present these data, because we have to be careful, because if we tell students that this particular drug affects the release of dopamine, for example, or different neurotransmitters, and it changes your brain this way, what we don't want to do is make these things more desirable for a student to take. So we have to be very careful of our message. People take drugs because it makes them feel better. And that's why people take drugs. But we have to be careful, because there's many downsides to taking these drugs. Addiction is a terrible, terrible disease. And a lot of other things come along with addiction. But just say no, and just presenting, how the brain changes with a particular drug, I don't think is enough. I think that we also have to add how addiction changes the brain, and some of the social consequences of taking drugs, and how that can affect us. So yes, I think that by knowing more about how the brain is affected by different choices that we make in our life can have a significant effect on children and how they will respond later in life.
I think there's something tricky about the word no. And it's probably one of the most common words that parents and educators use while raising their children. And it in a way, it might remove the element of empathy that should exist whenever we are trying to solve a problem, especially when it comes to a child or a teenager that's still trying to figure out life and have so much inside conflict going on to understand the outside world. So how do you think, instead of saying no, how can we navigate that in a general, not in a drugs aspect, or even in a neuroscience aspect?
Yeah, well, I think we need to do a lot more things. So yes, I do think that talking about the neurological underpinnings of how drugs affect the brain, they are important, because they show that taking these drugs changes our brain. So that's unquestionable. And so when our brain changes, it causes certain things to happen. So I think that it's important to show, the entire picture. And then I think, again, addiction is very important to touch on, and the social consequences that come with addiction. And a lot of the times what's not discussed are the legal implications of drugs. Whether or not we agree or disagree that drugs should be, and which drugs should be legal and which one are not. Our laws state that certain drugs, again, whether we agree or not, should be illegal. There are consequences of your behavior. And that is something that also I think needs to be wrapped up in not only the biology, the neuroscience, but we need to include the social and legal implications of using drugs.
It's about, I think, not giving youth a biology class. It's about giving them an educational resource where they can connect science with their daily life, because they don't see science, or even with the way the educational system is built now, they don't enjoy science. It's like making science enjoyable and connecting it with the social element of their lives, so that they can find a bridge, so that they can connect, oh, if I did this action, the consequence doesn't necessarily come from outside only. The consequence is only internal, because there's some sort of biological change that is happening.
Yeah, I think that's true. And there are some great teachers out there. Both of my parents were elementary school teachers. I know that there are good teachers. I think that they were very good teachers. And I've worked with teachers who have really developed fantastic programs related to neuroscience. And so there are ways to do it. Oftentimes, though, some teachers, because their hands are a bit tied, then they can't see the connection between neuroscience and what they're supposed to teach. Many teachers, they get guidelines from their states, which are often make their guidelines based on federal standards and things like this. But there are many ways that teachers have found to incorporate neuroscience into either their science classes or their health classes. Certainly in health classes, many times drugs of abuse are discussed, but also in biology classes, and maybe, as you know, in chemistry classes, you can incorporate neuroscience into many of those lessons.
Yeah, that's what's interesting about neuroscience. You can connect it to anything and it can work. I mean, you connect it to engineering specifically in your work, but you can also connect it to plants and herbs and pain.
Yeah, and even you can connect it to the social sciences. I mean, there's the relatively new field of neuroethics is philosophy. There's even neurolaw. There's neuroeconomics. There's all the neuroarchitecture. So neuroscience can be connected to every aspect of our lives.
Yeah, I would always joke that neuroscientists are adding neuro to every word. But like when someone really reads like what is neuroethics, what is neuroarchitecture, they could really understand what neuroscientists, their intention is, and it is like to design better policies or buildings that are just more accommodating to the brain, especially for neurodiverse individuals. And when we mention neuroethics, I think it's different than the neuroscience of ethics. There are certain problems like the trolley problem or some sort of problem that make us question and make a decision.
Yes, right. There are two aspects of it. There's the ethics of neuroscience, and there's the neuroscience of ethics. As you mentioned, the trolley problem where you pull the lever to make a decision. But then you might be looking at how someone's brain changes when they're faced with that moral or ethical decision. That's one type of neuroethics, and that's not really that's a separate scientific domain. The other domain, which I am mainly familiar with, is the neuroethics of neuroscience, and that is what happens to a person, for example, if they have a brain-computer interface. So does it, when you have a machine that's integrated with the brain, with the body, does it change how the person feels about themselves? Does it change the way a person views them? What type of security do we need around a device that's reading activity or maybe writing activity by stimulating the brain? So that's the type of neuroethics that I'm mainly familiar with. And I work with people here at the University of Washington who are experts in this field, that are in the Department of Philosophy. Dr. Sarah Garing, Dr. Aaron Klein run the neuroethics thrust of the Center for Neurotechnology. So they're really at the forefront of some of these issues.
So you have scientists and consultants working at the Neurotechnology Center to help you design devices that are ethical when it comes to the brain and the humans that are using the devices. And this is what a neuroethics specialist does.
Yeah, well, that's how we've envisioned it at the Center for Neurotechnology. Right. And it's not that the ethicists are, looking over the shoulder of the scientists to make sure that they do everything ethical. No, that's really not it. But rather, the neuroethicists are part of the research program. So we've had neuroethicists embedded in research labs as active research participants doing the research themselves. And we think that creates a very rich environment so that the scientists and engineers think about these issues before those issues cause problems later on. It's a way that the neuroethicists actually work together with the scientists and engineers as the research progresses.
Could you mention an example of a device that you have developed at your center and how a neuroethicist really supported the final outcome of this device?
Yes, so the one that I'm thinking of comes out of the Department of Electrical and Computer Engineering, where they were developing a closed-looped system for stimulating the brain, for example, to control Parkinson's disease. So this would, when a tremor arises, the stimulator will come on and it will reduce the tremor. So this is would be a deep brain stimulator to help someone with either essential tremor or Parkinson's disease.
And how would it work? If we could just dive a bit on how could it work at a neuroscientific level, like this.
Yeah. So there'd be biomarkers of tremor. It could be either muscle activity or brain activity. When the device detected that type of biomarker for movement, it would turn on an electrical stimulator that would then, I guess the best would be sort of short circuit that system, so that tremor would then be eliminated. So it would be able to read activity, and when that activity showed a particular pattern, it would turn the stimulator on. That stimulator would then stimulate the brain with electrical current that would then eliminate the tremor from happening. So
catch the threshold and silence the...
Correct. And then as the tremor went away, the stimulator can be turned off, and that's what I mean by a closed loop. So it's not just stimulating the brain constantly; it's only stimulating the brain when it's needed. So this would be a deep brain stimulator that someone would have implanted, and it would have a battery, and it would turn on and turn off as needed. So when you have one of these stimulators, after a while, a person might say, am I controlling that stimulator or somebody controlling me? Because it would come on without a person's conscious thought to flip a switch to turn it on or off. So a person might have a feeling of, who's actually in control of my body? Is it me, or is it a machine, or is it the doctors that set the stimulator up? And so these are questions of identity that a person might have after they have a stimulator like this. Another question that comes up would be security of these devices. So if this is a wireless device, and this was actually not a wireless, but if it was a wireless device stimulating the brain, could someone take control of that stimulator? Or could someone hack that stimulator and turn it on or off without the person's knowledge? So that would be bad. That would be bad. Questions about security, about identity. A person that has one of these stimulators, when they tell their friends or family might look at them and say, well, who are you now that you have this machine that's causing you to act a particular way? Would they treat this person in a different fashion now that they have this machine that's controlling their behavior? So these are questions that we don't all have answers to yet, but as these devices are getting more and more common, and people are getting these now implanted for other reasons other than just movement disorders, people are using these now to control pain, to control some mental conditions. They've been used for controlling addiction or obsessive compulsive disorder. There's some evidence to suggest that they work. We don't exactly know how they work, but we know that they can relieve these symptoms. Anyways, when you have one of these implanted into your body, will people view you in a different way? That, wait a second now, you're not who you were before, because now there's a machine controlling you. And how does that change a person's identity? How does someone view others who have these devices that are implanted?
And I think these are valid concerns that anyone who would want to put this kind of device could have. I mean, it's like having access to their anxiety about, like, they know that this device will help them, but the anxiety that how the society will view them is valid.
Right, and maybe as these devices become more common, some of these concerns might go away. Certainly, when we had drugs to control these, I think a lot of these drugs had a certain stigma attached to taking them. If someone was taking an antidepressant, and other people knew that might cause them to be viewed differently. Maybe now, because this field with brain-computer interfaces is so young, a stigma may still be attached to that, but maybe over time, as these become more common, maybe some of that stigma attached to having something interfacing with our nervous system might go away. So maybe that stigma will be reduced when these become more common.
And I think this is where neuroscience education also could play a role, because when we educate the people about this kind of device and how it is working on a neuroscience level, they'll be like, oh, okay, that makes sense to have this kind of device. It's not be this kind of abnormal addition on a person. It will look like a natural and normal solution to a problem that their brain is going through, like explaining the mechanisms, what the neuroscience of Parkinson's in that example of the brain electricity and how electricity works. This kind of education will be like, oh, okay, it makes sense to have this kind of device. And but if someone from maybe 50 years ago listened to us discuss about this kind of device, they'll be like, this is like a fiction, this is science fiction. And I'm interested in science fiction, and I know that you like sci-fi movies, specifically those that involve science. What is the boundary or the line between when something is realistically applicable and feasible and science fiction?
I'm one that I never say never. Certainly, if you look 50 years in the past and you see where we are right now, no one could ever have predicted this. Let me also say that I think that the brain is different. You know, for thousands of years, we've been trying to figure out the brain. And we still, our knowledge about the brain, we have a lot of knowledge. Don't get me wrong. We know a lot about how the brain works. But I think that some of the basic things about how the brain works, we still have no idea. I mean, I think the holy grail of neuroscience right now is consciousness. You know, what does it mean to be conscious? And I think if you ask 10 different people, what does it mean to be conscious? You come up with 10 different answers. And so, you know, where we'll be in 50 years, I don't think anybody can predict. But I'm a little wary about making predictions about the brain, because our basic knowledge about the brain is still quite limited. For example, you know, why do we sleep? What is consciousness? How do we make decisions? You know, how do we make moral and ethical decisions? These are things that we still don't really know about. And we haven't, to be honest with you, in my opinion, made a lot of progress. Even with all of the technical advances that we've made in neuroscience, our basic understanding about who we are and how we get our personality and our emotions and, as I mentioned, consciousness, I don't think that we're that far ahead. There are people much smarter than I am that are thinking about these questions, but in my opinion, I don't think that we're that much closer. So I do think that perhaps in 50 years, I do think that we'll have devices that will help people gain basic function back, being able to move again if they've suffered from, for example, a spinal cord injury. Maybe we'll have implants that will help us with things like stroke. But I don't know if we're going to be implanting these things in people to gain function. So there are a number of companies out there in the world that are creating these devices to help people right now with neurological disease. But there are also some companies that would like to implant these to enhance function. And whether or not as a society we actually want that or not, whether we'll create a divide in our society between people that can afford to have these implants to maybe communicate with the internet just by thinking about it, or whether that will even be possible, I don't know if that's something that society will accept. And so that's another reason why I think we all need to be knowledgeable about the brain, is because we may be voting on these things or spending our money on these things. And we have to decide whether we want these things, whether the benefit outweighs some of the disadvantage of some of these things. So a basic understanding about how the brain works and its limitations of some of these technologies is something that's very important, I think, for people to understand.
I think focusing on something that we need is what we need as a community. Because if someone has some sort of amputation and they would need to connect like a tech device where they could just think about moving the device that they are using on their arm, for example. That could be helpful and it could make someone's life better. But I just don't think as humans we need to just build these kind of devices that make us super. We don't need that. We just need devices that actually help people who need it.
Yes. So
this is what you're working on at the center.
Yes. We're not working on enhancement. But I happen to agree with you, but not everyone would agree with you. Some people would think, well, I would like to get better. I would like to have a better memory. I would like to be like Neo in the Matrix and being able to upload to speak a new language or fly a helicopter or whatever else is in that movie. Some people would say, well, I want to be better. We've always tried to enhance ourselves, either with better educational systems, technology. We're always trying to better ourselves. Whether or not we want to use these technologies to do that is a question that's open. Certainly there's big money behind enhancement. So not only for rehabilitation, but to enhance people who do not have a neurological problem. And so there's money behind this. And so because I think that there's money to be made, there's a case that some people might make to go beyond rehabilitation or retraining and go to that next level of enhancement, which is something, again, as a society, we'll have to decide whether we want that or not.
I totally agree with you. I just watched a movie this weekend called The Rise of the Planet of the Apes. Mm-hmm. And it's about a scientist that wants to cure Alzheimer's. And they're obviously testing on apes. And then the apes become super smart that they spread a virus. And I don't want to spoil the movie, but it didn't end in a good way. So I think we should be very cautious and utilize that the brain wants us to be better. It doesn't really need these kind of devices. Like these devices, yeah, they would be like enhancers and they would speed up the process and they would give us some sort of ability. But to these people who don't necessarily agree with me and you, and they think that we should have this kind of enhancements, how would you tell them from a neuroscience perspective, how can they become better without these kind of devices? Like, how can you be better just by utilizing what we have, the resources that we have now within reach?
Yeah, well, again, many of these companies are backed by big money, and so no one's going to listen to me.
But it could be any listener who's like not necessarily connected to these kind of companies, but is encouraging what they are doing.
Yes.
So.
Yes. So as you mentioned, yes, we've always looked for ways to make ourselves better. And unfortunately, humans, we often look for quick fixes, whether it's a pill we can take, like in the movie Limitless with Bradley Cooper, or Lucy with Scarlett Johansson, a quick fix. So I don't think that, brain implant, which is, most likely going to be a surgical implant, is going to do this. And I'm certainly not going to be the first one to line up for one of these surgeries. But I think that, yes, one way that we can immediately do it, and there's data to suggest that it works, is that having children know that their brain changes can actually enhance academic performance. This is some work that's been known for more than 10 years, maybe closer to 20 years, that by teaching children that their brain changes can actually improve their classroom performance. So a very simple fix, just have a few lessons showing the children that their brain is plastic and that it can change over time. When they know that their brains can change, that opens up the possibilities for children to learn better. Whenever we learn something new, whether it's from a success or a failure, that's our brain changing. So just that knowledge about how our experiences changes our brain can make a big difference.
Yeah. Moving to a more safer technology improvement, how do you think technology will shape education in general moving forward?
Yeah, that's a good question. I mean, I don't know. Maybe AI is the next change that's going to be sweeping our education system. It's still a little bit too new to find out. I think the advent of the internet, nobody could really predict how that was going to take over. But I think that reading press reports and hearing what people are doing with AI might be our next big revolution in education. I'm not sure, because maybe it's just too new, about how teachers are using it in their classrooms. So I don't know, but I have a feeling that artificial intelligence might be our next big technological change in our education system. There's lots of different uses of AI. I mean, my own personal view is that AI is good for some things. It has to be used carefully. I always tell my students, yes, you can use AI to get ideas, but don't copy and paste. And double and triple check any information that you get with other reliable sources. The hallucinations of AI are a problem. So I think it's a good starting point, but it's not the end point. So students can use it, but it has to be used carefully.
And one thing not everyone knows who aren't in the tech or neuroscience field is that AI and neuroscience are really close knitted to each other. Could you tell us a bit about the relationship between AI and neuroscience and some of the fields that are individual fields that people are studying? And you mentioned a couple in the beginning of our conversation, but could you just tell us about this kind of dynamics that's happening between neuroscience and AI and how both of them kind of could hold each other's hands and grow together?
Yes. Yeah. I'll give a couple examples where I think AI can be very, very useful in neuroscience. One is big data. That is, these days, neuroscientists can record from hundreds, if not thousands, of neurons simultaneously. And they're generating massive amounts of data that would be impossible for an individual or even a team to analyze. So AI can be used to look for patterns in these particular big sets of data much more efficiently than us lowly humans could do. So using AI for data analysis is going to be a very, very big thing. Another role for AI, I think, is collaborating with neuroimaging. So looking at either PET data or magnetic resonance imaging data, looking at a particular image, being able to analyze what this image looks like and helping with diagnoses of a particular condition. So again, not leaving it completely up to AI, but maybe having AI look at a particular image, making a recommendation or suggesting to a clinician that perhaps you need to think about this particular diagnosis. What I mean by neuroimaging is I mean a brain scan, such as a magnetic resonance image, which shows the structure of the brain, or a PET scan, positron emission tomography, which looks at brain activity. People may have seen a brain image that have different colors, and the brighter colors usually illustrate more activity in a particular area. Well, by using these brain scans, clinicians can diagnose disease and look at recovery after disease, maybe after a particular treatment. These brain images are not always easy to analyze just with the eye. Sometimes it's very obvious, but other times there are subtle changes in what these brain images look like. So using AI might be able to analyze those images more efficiently than a clinician just looking at it. So in that way, a clinician might have a better idea, or maybe a faster idea, about what is happening with one of their patients. But again, like using ChatGPT to give you an answer, I think that I would not leave it completely up to the AI to make that decision. I think that it has to be double and triple checked by someone who has the knowledge about a particular patient to either confirm or refute the diagnosis that AI might provide.
It's nice that this is the kind of work, especially in your neurotechnology center, that you supervise the technology aspect, but also in your research aspect, you're kind of also connected to nature and you're studying how nature could help us as humans. You could just explain the scope of that and what do we mean by the relationship between medicinal herbs and the brain?
Sure. Yeah, I was involved in a couple different programs. My main interest in the neuroactive properties of medicinal plants and of herbs came about several years ago, where I actually had a grant that I called NeuroSeeds, and this was a program that I built all around medicinal plants for educational purposes for middle school students. So that's how my interest got started, and we made lessons and I can send you the link to the materials are all still available. And this was a program for middle school students to get them interested in neuroscience, but by introducing it via plants, because many students maybe have a home garden, and certainly on the way to walking to school, they see plants and trees all around them. The University of Washington has a fantastic medicinal herb garden. They probably have hundreds of different plants, and they're labeled with the scientific name and the common name. What I've done is I've gone through the garden. I haven't explored every single plant, and I've looked at particular plants that we have extracted medication from, or we've created medicine from. Some of these plants have better experimental evidence to suggest their efficacy. Other plants have more anecdotal evidence. For example, they've been used for folk remedies for many years. There may be some data to suggest it works, but maybe it's not as strong as for other plants. And so what I do is I take the students and we go from plant to plant. Many of the plants have a big smell to them, and so they can smell the plants, and we talk about the different medicines or the different conditions that are treated via extracts from these different plants. Some of the plants people have made tea from. Other plants the active compounds are extracted and they're used in pill form. So I think it's just another way to connect students to neuroscience, and plants I've found to be a good way.
It is, and it's a very immersive learning experience, because going out of the classroom and kind of like we were talking about technology, but like actually dissociating from technology a bit could be really helpful to the brain, and they're learning about things that they could connect to their daily lives. For example, like I'm a regular consumer of mint tea, and I think many people enjoy mint tea. So whenever like they would drink that kind of tea, they'd be like, oh, it does that to my brain. And this is the beauty of neuroscience education. It's this seamless way to connect everything that we do to our brain, which makes us appreciate how the brain actually works so hard to manage all of our lives, all of the stimulants, all of whatever is happening inside of us and outside of us, which I think is really incredible ability. And this is why, and I think you agree on this, that it's the most important part of the human body.
Yes, I do. And going out to that medicinal garden, getting the students outside of the classroom environment, I think is very powerful. And I've just been very lucky to work in the Center for Neurotechnology. I mean, the Center for Neurotechnology right now is managed by Dr. Raj Rao, who's a professor in computer science and engineering, and Dr. 𝗘𝗿𝗵𝗂𝗍, who's a professor in rehab medicine. And so they're the directors of the center, and they've given me a lot of freedom to create these programs because they see the vision and the importance of working with young students. And so it's just been great working with Dr. Rao and Dr. 𝗘𝗵𝗂𝗍, who manage this center, because they've given me freedom to create these programs, and they see the value.
I also read that you traveled to India to teach neuroscience there to Buddhists and monks. What kind of neuroscience would you teach them?
Yes, so it was probably about 12 years ago that I was just contacted out of the blue by a program that was called Science for Monks. Changed the name now. It's called Science for Monks and Nuns. And this was a program, again, I'm not associated with the organization. They kind of just asked me if I would like to come to India to teach Tibetan Buddhist monks and nuns. And my parents had actually lived in India for 5 years. I was in college and graduate school at the time, so I kind of knew what it was all about and traveling to India. And so when they asked me to go, I agreed. And since then, I've gone 8 more times. I didn't go during the pandemic, but the last time was probably 2022 or something like that, or maybe 23. I can't remember. Oh, it was actually 22. It was spring of 2023 was my last visit. Any of the activities that I developed for neuroscience for kids, I use when I teach the monks and nuns. Although few of them speak any English, and I don't speak any Tibetan, although they did teach me how to count up to 10. But many of the activities that I use to teach children are the same activities that I use to teach the monks and nuns. So it's very similar that I do a little bit of lecture to give them a basic understanding, and then activities to reinforce a lot of the concepts that I use. So even though the activities were developed for children, I think that they're good for anybody of any age. They're very simple, and I think that they do a good job relating concepts back to them. The lectures start with neurotransmission, which I mentioned before. We talk about memory. I do a little bit on consciousness because the Tibetan Buddhists have been thinking about the brain and consciousness for thousands of years. But they have a very different idea about consciousness than Western science. And so they kind of wanted to hear, how does Western science approach consciousness? And they contrast it to their own view of consciousness. So I do a little bit of how Western science has approached consciousness through drugs, through brain injury, through sleep is another way to talk about consciousness, at least from the Western perspective. And they then can relate it back to their own teachings and some of the things that they've learned over time. But it's a great group of students. It's always a different, every time I've gone, it's a different set of students. They're always very interested in what I have to say, very open to learning. In fact, I think they're the best students that I've ever had. They don't always agree with what I have to say based on some of their teaching, but they're always interested and open to hearing what I have to say.
Do they share with you some of their beliefs and their training on the brain?
They have. It mainly is, whenever we get one of these discussions, they always turn it back to me and they say, we want to hear from you. But I've tried to, yes, I have tried to learn from them, but there are many differences. And I think the major differences between how I view the brain and the mind is that they do not believe that the brain can create the mind. And that's something that maybe has to do with their different idea of what consciousness is. So they have no problem with the brain is related to sleep. When you take a particular drug, it changes the way the brain. But their idea of consciousness is much different than my own view of consciousness.
Then it's not biology.
Yeah, yes, that's correct. I mean, I believe that, yes, that the brain or the mind is a product of the brain, but they don't. That they believe that once the brain dies, the mind continues someplace else. And they may be right. I'm one of these people that I don't know. As a scientist, I don't know of what experiment to test that would give me some of these answers. So after death, where does the mind go? I don't know the answer to that question. As a scientist, I need to devise an experiment that would give me that answer. And I don't know what experiment I would use to give me that answer. So what happens to the mind after we die? I don't know. So there are certain things that we talk about that sort of stop abruptly. because oftentimes when they ask me a question like that, where in the brain is consciousness? I tell them, I don't know. And they sometimes get a little bit frustrated because here I come all the way from the United States. I should have all the answers. I tried to tell them that in science, saying I don't know is not a bad thing. Saying I don't know leads to more questions, which is what scientists like. So sometimes they might get a little bit frustrated with me when I don't have all the answers. And I tell them up front, I don't have all the answers to your questions. Scientists, we don't have all the answers. It's just, that's a fact. And so I think that some of the difficulties that I have, one is related to language, in that a lot of the concepts that they have don't easily translate into English. And there are other things that their belief system that I just don't have any answers to, or I don't know of any experimental evidence that would either confirm or refute some of the things that they believe.
Because I think the most straightforward questions are the hardest usually. And these are the questions that are still people are thinking about, and everyone has their own views, like what is the self? What is the mind? What is consciousness? Where does it come from? Where does it go after the body dies? So these are all hard questions. And as you just mentioned, it's hard to design an experiment that could give us answers to. One concept that I like is the concept of energy. The brain runs on energy and the universe runs on energy. Would you equate energy with mind?
Yeah, well, I mean, again, like you say, the simple questions are sometimes the most difficult to answer. I would say that this is my own personal opinion. After someone dies, they don't go away because it's still in our collective memory of the people that are left behind. So there's something that remains. Can you quantify it? Can you put your hand on it? No. But there's something that's still there, and it resides in our collective memories of that person who's no longer there. So is that a form of energy? Maybe, because our brains are creating energy every time we think of that person. But it's difficult to measure, but something remains. But what that something is, I don't think that we actually know what that is.
Yeah. I think people should accept that science doesn't have the answers to, at least for now. And it does require a bit of everything, like a bit of science, a bit of history, a bit of psychology, a bit of philosophy to try to put the pieces together.
Yeah, I mean, even physics is getting into the game now with theories. Yeah, exactly. And I'm not exactly sure how it fits, but as you say, every aspect of the sciences and the social sciences are involved.
You also mentioned that your parents were educators, and this has been a big element into your education practice, because especially as a scientist, education is something that, and we mentioned it, but it's something that you do because you want to. You really don't need to, because you already have lots going on when it comes to your research. And I think it requires us to be really inspired by the people around us. How do you think we can inspire others to change something within them and to do something?
I think the way to do that is by showing people how much you enjoy doing what you do. Certainly, when I talk to students of all ages, I try to show them how excited I am about the brain, how excited I am about the work that I'm doing. And so I think by conveying your interest and your passion, your excitement about whatever it is that you're doing, I think is one way to motivate students. So I think just showing that excitement that you have about a particular topic is one way to get students interested.
Yeah, spreading the energy of your interest, and it's really important, because especially you're in a faculty position, so you're surrounded by lots of undergrads and graduate students. And personally, whenever I see someone who is a faculty member or a director that is doing this kind of communication and outreach work, it really moves something inside of me, because I know that they can, like, they are choosing to do this. They are choosing to communicate their work and take it out of the lab, and this is something I really appreciate. And for me, at least, it's a variable where whenever I want to like take a course with a professor or work in a lab of the professor, because and last semester that was one of the criteria of me choosing my professors. I mean, some students go to the Rate My Professor website. I go to YouTube to see if this professor has any online lectures. So I think this kind of sharing your enjoyment about the topic and how much a professor is excited about it could really inspire students or educators to talk with them, to learn from them, because they know that they won't use this kind of neuroscience language that they wouldn't know.
Yeah, so I would agree with you, but not everyone would agree with us. And that is, I have worked with several graduate students who have shown an interest in outreach, and they have been discouraged from pursuing that avenue by their lab directors. And the reason for this is because a particular lab director would say, I'm paying you to be in the lab. I'm not paying you to use your time to go into schools. And as a lab director who has limited funds and limited time, that student is required in the lab, not going out to schools or doing this. My own personal opinion is that is a very limited view. And in that, the skills that a graduate student can gain from working with the public, by working with teachers, by translating their own work into common language, is a skill that directly applies to their graduate work. If a graduate student cannot communicate what they're doing, then they're at a disadvantage of that next level. So I think that a lab director who prohibits a graduate student from doing outreach, I think, is taking a very limited view of the skills that are necessary to be a successful scientist. So I try to encourage, certainly if a graduate student is not in my lab but in another lab, I try to give them that type of information that they can take back to their lab directors and their PIs to suggest that perhaps it is a very useful thing to do for a graduate or even an undergraduate student to do, because there are these skills that you gain outside of the lab that are very, very important to you. So many students have been successful in using that information to convince their lab directors to allow them to go out and do this. And I think it's changing over time, because organizations like the Society for Neuroscience see the value in public outreach. And when an organization like the Society for Neuroscience gives their blessing to doing outreach and showing the importance to the community of how important it is, I think then that trickles down to lab directors, which then see the value of allowing or contributing themselves to community outreach and education.
And I think especially when it comes to fields like neuroscience or any other field that is in the public health, and I would consider neuroscience to be in the public health field to some degree. Why keep this information in the lab? Why not take it to, like, what's the point if someone is choosing to study neuroscience or health or any other field that will serve people? That the most straightforward thing to do is to communicate that work to the people wherever they are. And there are lots of communities that need this kind of education, lots of vulnerable communities that would be benefited from this kind of education and knowledge.
Yes, well, I'd take it a step even further. than what you just mentioned. I believe that it's an obligation of everyone who is getting money from, most of us get money from the federal government. I think it's an obligation that we give back to the people that are contributing to our work. So it's not something that I think should be, it should not be a choice. It should almost be a requirement that if you get money from, especially the federal government, tax dollars that are paying for your work, you should be obligated, you should be required to give back. And it's true that some, like the National Science Foundation, build this into many of their grants. So there's a broader impact statement. You have to show how you're going to disseminate this information to the wider audience. So I think the National Science Foundation has got it right. There are some people that are working behind the scenes that are trying to get this into the National Institutes of Health, but have not been as successful. But at least the National Science Foundation makes it clear that public communication and dissemination of information to places outside of the scientific community are essential for a research program. So I think the NSF, the National Science Foundation, has got it right.
And I'd like to end the conversation on this note, because I think this is one of the most important takeaways, specifically for the scientific community, because as you mentioned, it is an obligation, and I really would love to see more outreach in neuroscience, but also in like any field, honestly, because anything can be dismantled into tangible, simple information, especially with the internet and how it's now easy to find an audience and communicate and connect with people all around the world.
I agree completely. And like you said, I believe it should be an obligation to communicate your science, but I think that people can make it something enjoyable and part of their career. It's something that young scientists, old scientists, we have to do it all the time. So becoming good at it, I think, is something that will all serve us to the better.
Yeah, exactly. It's also like a joint work that could happen between scientists, because I know that not every scientist could build an educational curriculum or have the time to do it. So it's a joint work between curriculum designers, educators, scientists to truly build this kind of immersive experiences that people at any age could learn, because learning never stops. And we here focus maybe at the K-12 levels, but it's honestly at any point of life. And if it's something that people could improve and it could help make their lives better, it is a necessity and a responsibility.
I agree. Now, not every scientist are trained to do this, but like you said, it should be a collaboration. We have experts in scientific communication, people in the communication school, educators, and so we need the experts to help scientists gain these skills, because there are tips and tricks and things that you should and shouldn't do, and scientists we're not always trained to do those things. And so by working with experts in other domains who are familiar with the techniques and best practices can certainly contribute quite a bit.
Thank you for joining me in this conversation with Dr. Eric Chudler. Please see the description of this video for the links to his website, to his lab, and to any relevant website that is mentioned. Also, please subscribe to this YouTube channel, as I plan to host these kind of discussions frequently with academics who are interested in science communication and the neuroscience education and community outreach. If you have any questions or topic suggestion, please leave them in the comment and leave your feedback as well. It really matters to me, as I will need your comments to improve the quality of this show. I also share neuroscience content on Instagram. My business website is also linked below, where you could see the service that I am providing for elementary and middle school students to teach them neuroscience using a gamified and an immersive model. Thank you so much for tuning in to this conversation. I really hope that you gained new insights on neuroscience and education.